You ever step outside, just look up at a towering skyline, or maybe gaze down a sprawling highway, or even just turn on your tap and watch the water flow out, and think, how does this actually all work? Like, how does the modern world literally get built from scratch? Well, today, we're going to break down the anatomy of a city and demystify the incredible and honestly often totally unseen work that makes modern human life possible. The sheer scale and precision of what we're about to look at, it's truly mind-blowing.
I mean, really think about it. The buildings we spend our days in, the roads we commute on, the massive bridges connecting entirely separate cities. Who's actually responsible for taking those monumental concepts and turning them into a physical, safe reality? The answer, as you might have guessed, is civil engineers.
Okay, let's dive into this. Today we're covering 1. The invisible architects. 2. From the ground up. 3. Connecting the modern world. 4. Tools of the trade. And finally, Part 5. Building your career.
All right, starting things off with Section 1, the invisible architects, before the shovel hits the dirt.
So, when we hear construction, we usually picture cranes, hard hats, heavy machinery, right? But civil engineering is actually the whole shebang: the planning, design, construction, and the maintenance of infrastructure. It's actually one of the oldest and most vital branches of engineering in human history. And the absolute key here is that these projects support everyday life. We're not just talking about giant, flashy monuments. We're talking about the houses we sleep in, the schools we learn in, the highways we travel, and the dams generating our power. Civil engineers are literally building the world right around us.
And you know, the sheer amount of unseen rigor that happens before a single shovel even touches the dirt, it's staggering. First, engineers have to study the project site and conduct intensive surveys. Then, they analyze soil conditions, which, by the way, is a step that can literally make or break an entire project. And only after all of that do they prepare the detailed designs. Oh, and during this exact same phase, they're also estimating massive project costs and making absolutely sure that all safety and quality standards are going to be met. It's a monumental puzzle of planning.
Moving right along to Section 2, from the ground up: soil, steel, and structures.
So there are basically two completely different but totally complementary worlds at play here. First, you've got structural engineering. This handles the visible world, the buildings, the bridges, the towers. Their job is to make sure these structures can safely withstand some pretty staggering loads. And when we say loads, we don't just mean the dead weight of the building itself. We mean the dynamic weight of thousands of people, moving vehicles, the brute force of high winds, and even the violent shaking of earthquakes. To do this, they typically rely on materials like reinforced concrete and steel. But on the flip side, geotechnical engineering handles the invisible world, the soil below. Before a single piece of steel goes up, geotechnical engineers have to understand the strength and the behavior of the dirt itself. A strong foundation is absolutely essential, right? Because its entire purpose is to safely transfer the massive load of the structure above directly into the ground. If the geotechnical engineering fails, well, the structural engineering just doesn't stand a chance.
To actually execute both of these intricate designs, construction engineering and management steps in to bring the blueprints to life. These folks supervise the projects right there on the site. They manage the immense labor force and literal mountains of materials. They monitor incredibly strict schedules, ensure total safety compliance, and desperately work to keep everything within budget. They're essentially the conductors of this massive construction orchestra.
Which brings us to Section 3, connecting the modern world, transit and water systems.
Zooming out to the macro level for a second, cities function as a whole by relying on two major arteries of civilization. First up, transportation engineering. This focuses on the flow of society, designing our roads, railways, and airports. Their ultimate goal? To improve traffic flow, increase safety, and create efficient systems that directly support a region's economic growth. I mean, if goods and people can't move, a city basically dies. Alongside that flow of traffic is the literal lifeblood of the community: water resources engineering. This side of things deals with our water supply, drainage, dams, and flood control. These engineers are tasked with managing our most precious resource effectively while simultaneously protecting entire communities from devastating floods.
And this brilliantly illustrates how infrastructure supports everyday life for millions. Think about your own day-to-day. Whether you're just turning on a tap to brush your teeth, catching a flight across the country, or driving down the street to the grocery store, you are relying entirely on these interconnected systems designed by civil engineers.
All right, let's look at Section 4, tools of the trade: the high-tech engineer.
Now, you might still be picturing someone hunched over a drafting table with a pencil and a protractor. But to pull this off today, the modern engineer relies on some absolute powerhouse industry-standard software. We're talking AutoCAD, Civil 3D, ETABS, SAP 2000, Revit. These digital tools run incredibly complex structural analyses. They actually allow engineers to simulate real-world stresses, like hurricane-force winds or severe seismic tremors, on a digital skyscraper before a single physical beam is ever even ordered.
But the industry is pushing even further. Next-generation technology is already here. We're talking about deploying drones for hyper-fast, centimeter-accurate site surveying. Things like building information modeling, or BIM, which creates these amazing, interactive, shared 3D blueprints. And now, artificial intelligence is being heavily leveraged to optimize massive supply chains and, get this, literally predict project delays before they even happen. It's a remarkably high-tech industry.
And finally, Section 5, Building Your Career, Paths in Civil Engineering.
So you might be wondering, how does someone actually enter this field? Well, it takes a pretty unique balance. You definitely need the hard technical skills, a strong foundation in advanced math and physics, plus a really deep expertise in construction materials. But you can't just be a numbers person in a vacuum, right? Because you're managing massive teams and huge budgets, rapid problem-solving abilities, and top-notch communication skills are equally critical. And of course, nothing replaces practical on-site experience to truly understand how all these things go together in the dirt.
Master those skills, though, and the paths are incredibly vast. You could be the site engineer with your boots on the ground, the design engineer drafting up the future, the quantity surveyor managing the heavy economics, a planning engineer mapping it out, or the project manager conducting the entire symphony. All of these professionals work in tandem on projects that don't just build companies, but actually improve entire communities and directly contribute to national development.
So the crucial point is this quote right here. Civil engineering is much more than building structures. It is about creating safe, sustainable, and efficient infrastructure that improves the quality of life. Every road, every bridge, every building, and every water system we interact with today, none of it is an accident of nature. It's the direct result of the knowledge, the skills, and the unwavering dedication of civil engineers.
If you found this explainer helpful in demystifying the incredible world around you, definitely please like, subscribe, and follow for more knowledge and insights. I'll catch you on the next explainer. But as you walk out your front door today, hopefully with a profound new appreciation for the infrastructure supporting your life, I want to leave you with this. The built environment is an absolute human triumph. So, how will you shape the world?